you could place in a tiny laboratory for analysis. Meanwhile, the Viking's cameras would scan its surroundings, and a small radio dish would manfully relay all the pictures and data back to Earth. This particular Viking was road-tested in some of the harshest deserts on our planet Earth, and so scientists thought they knew what to expect.
But what kinds of life forms might cope with the special problems of Mars? The Mars atmosphere allows deadly ultraviolet radiation from the sun. Life forms on Mars may have silica shells to protect them against the radiation. We know that Mars is very dry. Life forms on Mars may have developed special ways of preserving their water content, and those forms may not look familiar to us. I could imagine a kind of plant that is indeed an ice eater, with fine root-like structures, searching not for liquid water, but searching the permafrost, reaching down to get at that ice.
In those very early heady days, there were some people who thought we might find visible signs of life, maybe be able to take a picture of life. That was pretty fanciful, but it was possible. But for the most part, we were looking for things that were very small, tiny, below the level of the human eye, that you would have to, we didn't carry a microscope, of course. We really took chemical kinds of experiments. We took small samples of the soil and looked for the kind of things that biology do.
5, 4, 3, separation.
July 1976, and hopes are high as Viking 1 approaches Mars. At mission control, scientists follow the lander's descent with bated breath.
We were at the command center at the Jet Propulsion Laboratory in Pasadena, California, where all of the teams had, of course, assembled for the mission. And as we heard over the speakers and watched our monitors the various altitudes of the spacecraft, why we were, of course, very excited and filled with great anticipation.
23 inches, 2,600 feet, 188 feet per second.
2,600 feet! 2,600 feet!
For 366 feet,
73 feet per second.
come on. ACS is close to vertical.
Nav is green for touchdown.
ACS is green, 1.5 degrees per second max, 0.2 Gs, 50 feet per second. Touchdown wind.
The 5 years of planning paid off. Viking was safely down and ready to begin its first-hand inspection of Mars.
Yes, the first pictures didn't come back until about 30 to 35 minutes after landing, so that was a long time that we had to wait to know whether the cameras were actually going to work. And it was a suspenseful time as we waited. But then when the pictures started, they were painted on the monitor a line at a time, and so it was we had to wait and watch the picture as it unfolded, and that was quite exciting.
Elliot, what do the pictures show us?
Well, the first picture was planned to take a scene from one footpad to the other so we could see what the surface was like and what interaction this footpad had with the surface. Then the next picture was a panorama that took the horizon, and that showed us what the far field looked like. The horizon on Mars, since it's a smaller planet than Earth, is only several kilometers away. And on the horizon we could see the rim of a crater and some large rocks of various types, a very rocky scene. There were rocks several meters across on the rim of a crater on the horizon. And then there was one about 9 meters from the spacecraft. There was a large rock that we called Big Bertha, but we changed the name to Big Joe because some of the ladies didn't like Big Bertha.
But Viking didn't just see Mars in black and white. Within hours, the first color pictures of the red planet started to come in.
First, we expected the sky to be somewhat here on Earth. It has an atmosphere, so we thought it would be kind of bluish. But as we processed the colored pictures, we discovered that the sky was pink. And the reason it was pink was because a lot of that red Martian dust was just still in the sky, which give it that pink color.
Viking had a lot more to do than just send back holiday snaps. Its long scoop, here being tested on the Earth, was designed to feed the Martian soil into a miniature laboratory which would check for signs of life. The whole operation had to be done by remote control. But how would Viking recognize life? It was designed to look for organics, chemicals which would form life given half the chance, and also for microscopic living cells in the Martian soil.
And what kind of things did you detect coming off in these experiments?
Well, that was a surprise. In fact, there were two remarkable surprises in Viking. One was the fact that we didn't find any organics, any of these chemicals that life is made, and that really perplexed us. How could there not be any organics, since there was every reason to think that we would find organics that came from meteorites or that came from just the synthesis of the normal chemistry of Mars, but not finding any was very surprising.
How weird.
In one of the experiments, a really surprising thing happened. We call it the chicken soup experiment, where we dumped a bunch of stuff in there and hoping that if there's a Martian organism there, it might like to eat the chicken soup. It wasn't really chicken soup, of course. But to our amazement, what happened is oxygen started coming off, as though there were some very funny thing breathing out a lot of oxygen.
On board the lander was a miniature laboratory, no larger than a big waste paper basket. It contained 3 automatic experiments. The chicken soup experiment was designed to look for the activity of living cells in the soil. A small amount of nutrient, the chicken soup, ran down to the bottom of the container. It gave off water vapor which moistened the soil. At this stage, any cells present should not have responded. But to the scientists' surprise, the moistened soil very quickly produced lots of oxygen gas. And then as quickly as it had started, it suddenly stopped. Was it life that had produced this sudden burst of oxygen?
Well, the current explanation is that probably there are these peroxides on Mars.
That's the kind of thing you put in your hair to make it blonde?
Yeah, that's right. The kind of stuff, probably not hydrogen peroxide, which is the kind you find in the drugstore or in the pharmacy. Probably iron oxide, since there's a lot of iron on Mars. But does the same thing. It's highly oxidizing. And in some ways, I guess you might say it tends to sterilize the surface. It destroys those organics that ever get started.
So if life chemicals are so common in space, they're common on the Earth, they're common in meteorites, they're common way out beyond the solar system,
Why aren't
they
there
on
any
Mars?
Right, great question. Wish we knew the answer to that. That's why we're going to have to go back again and answer all those questions.
The closest we can come to Mars on Earth is in a barren desert like this one. In fact, to look at, the two are very similar. The same pinkish-coloured soil, the same dark volcanic rocks. But Mars is a great deal more barren. The Viking landers have shown us that, life or no life, Mars's soil has a peculiar chemistry. Its thin atmosphere has no protective ozone layer, unlike here on Earth. Without this sunscreen, the merciless ultraviolet rays of the sun beat down unchecked, sterilizing the Martian soil. In the past, conditions may have been kinder and life may have started. But without an ozone layer, it would have had a mighty struggle to survive. While here on Earth, our sunscreen protects life. And as a result, it can flourish in even the most unexpected and hostile environments. Meanwhile, pictures were being received on Earth from the 2 Viking orbiter craft high above the Martian surface. Over a period of 6 years, they sent back thousands of images. And as a result, we know the face of Mars today more thoroughly than that of any other planet, including our own. Even though the Viking mission is over, we are still learning more from the data as our computer power increases. With the computer's aid, we can fly over Mars's huge volcano Olympus Mons, 3 times the height of Mount Everest. That's something which would have been undreamt of when the mission first started. we can survey the ins and outs of the planet-wide Valles Marineris Canyon system, a system so big that it forms a vast scar on Mars's surface. The Valles Marineris is one of the prime targets for when we next go to Mars.
We have a long way to go and lots of steps to fill in before we send people. For example, we got lots of pictures with Viking, and we have beautiful pictures of local areas, and we're drawing geologic maps of those showing where the rocks are. But we didn't have chemistry. So the next thing we do is we send an orbiter to determine what the chemistry is. That's sort of a mid-year exam. You see, we've drawn these lines that says what the chemistry is, and we'll find out whether we pass or flunk. And then the final exam is when we send a lander with a rover that runs around and collects samples that we bring back. And that's the final exam.
Will this rover be manned or unmanned, Hal?
We could do it either way. We could take the pictures and the chemical data and send the unmanned rover and say, you know, stop here and pick up samples. We'd like to do it with a man because a man is cleverer and more flexible, and we're looking for very subtle things like soil horizons. And the man could go just to the right place to pick the right samples up.
In Tucson, Arizona, a prototype for the first unmanned Mars rover is taking shape.
Yeah, the relief valve is operating. We got about 24
It's not being designed by a giant aerospace corporation, but by a group of students commissioned by NASA.
There have been designs which have had sort of small wheels and intelligent sensor systems and intelligent decision-making programs, but that costs a lot of money. And the idea of this is it's much cheaper if it doesn't need that intelligence. If we have these huge wheels, we don't have to be that fussy about where we can just drive over most of the obstacles on the planet.
How fast will it move over the Martian surface?
About
a kilometer a day.
Kilometer a day, is it? Growing a lot.
Yes.
Okay, so you can see each one of these valves goes to a sector, and like we saw over there, and can either inflate or deflate it.
Yeah.
And then we use the computer to tell it to roll in different directions.
A small model of the Mars ball shows off its paces on the University of Arizona campus. The actual vehicle, if it ever gets there, will stand 16 feet high.
I don't like to ask this question. What happens if one of those gets jammed?
Well, we don't like to answer that question. If it happens when we're testing it in Arizona, we can just go out and hit it with a hammer. If it happens on Mars, we may be in trouble, and that's why it would have to be very carefully designed.
Or you need Martians to help you.
That's right, yeah.
Should man ever go to Mars, he'll certainly face problems. For a start, there's the distance. The round trip takes about 2 years, and that's one reason why the Russians, in their Salyut space station, are experimenting with long-duration spaceflight. What's the effect of weightlessness on the human body over long periods? And can you wash away the psychological problems of living in space in a space station shower? Worst of all, space gets into your bones in the most insidious way. Prolonged space living makes your bones brittle, and although vigorous exercising lessens the effect, it won't go away. But we're getting there. Russian cosmonauts have managed to live in space for periods of nearly a year. They claim that within 15 years, man will set foot on Mars. At a secret location in England, even longer-term plans are being laid.
It's pretty clear that the scientists have done their homework on ways of keeping people alive in spaceships, but we don't think that the social scientists have done their homework very well. And we actually don't know whether a mixed group of people are going to be able to live together in harmony for the duration of some of the early settlements on another planet.
A group of English social scientists is persuading 15 volunteers to give up a year of their normal lives to live in a complete simulation of a Martian base. As they work, rest and play, their every action will be watched by television cameras that record how people actually get on with each other under the very demanding conditions that real Mars settlers will suffer. What about pleasures? Will they have any fun things to do?
Oh yes, we'll have a library of tapes of entertainment and music and films and things like that, and they'll also be able to phone home. But
there are other problems there?
Well, there is one very big problem. There's a 60-minute delay, which we'll have to construct an artificial delay, which might cause problems.
When is all this going to happen?
Well, we're hoping it'll get going in about a year. It'll take a lot of planning, and it also take a lot of money.
This idea is not as bizarre as it sounds. Scientists are already using the Viking data to select possible sites for a base on Mars. Hal, what do you think of the idea of establishing a manned Martian base?
It may seem far-fetched, but it's entirely feasible. The biggest thing is that unlike the moon, Mars has lots of water, and that's what we need for life.
So where would you put this base?
Well, the easiest place, that is where water is most available, is near the North Polar Cap, which is lots of water ice. And all you have to do is use solar heaters and melt it.
Well, you've mentioned all these missions, like the Observer, the roving vehicle, a manned flight, and possibly even a colony one day. It all sounds like science fiction. When's all this going to happen?
Well, it would take a lot of time because we have to do it one step at a time. We have approval for the Mars Observer mission to determine the chemistry. That flies in 1990. There are people who think that we might fly a lander rover sample return mission in, say, the mid-1990s, 1995, 1996, and perhaps a manned mission 10 years after that, and the Mars base 10 or 15 years after that. That sounds like a very long time, but we have to build this a step at a time, and if we intend to go in that direction, we have to make the plans now. When we first talked about these very long missions, one of the people said, "My goodness, I won't be around. It will be the sons of my graduate students. It'll be a new experience in human history." And I said, "Remember the medieval cathedrals? They took 200 years to build."
There are plenty of mysteries left for future missions to Mars. And the question of life is still top of the list. We know that Mars's soil has been thoroughly sterilized by the sun's radiation. But did life ever develop during Mars's warm and wet past? Might scientists one day find fossils buried deep in the ancient rocks of Mars's giant canyons?
Some of us feel that, some of us, I sit on both sides, feel that maybe there never was life on Mars. Maybe it was always this way. And others feel it's possible that today's Mars is different than it was, say, 2-3 billion years ago. I think we're not going to know until we actually carry out the right experiments.
And go there?
Right. I think the only solution, as science always does, is you have to do an experiment. You have to go there. You either have to have people there, you have to have spacecraft there that actually go look for fossils or look for meteorites or look for something. Until we have exhausted ourselves, we just won't know the answer to that.
Well, let's wish the next generation the best of luck in getting there and finding out.
Let's give them everything.
So Lowell decided to start an observatory.
They might find fossils when they get there, but they won't find Percival Lowell's canals.
The longer he looked at Mars, the more of these lines that he thought he saw. And so he thought that they were canals. And this meant there must be people on Mars to build these straight canals. But it turns out that all Lowell was really seeing was just an optical illusion through the eyepiece. It could be that his eyes just wanted to draw lines between the dark and light areas on the planet, or possibly the optical arrangement of the telescope was accentuating that, was making the light areas lighter, the dark areas darker, and was making him think he saw those lines when they weren't really there.
Perhaps Percival Lowell did get too carried away by his own enthusiasm for Martian canals. But his conviction about life on Mars was the spur to research leading to the Viking landers and to the next round of American and Russian spacecraft that will photograph Mars and roll around its bare deserts. And beyond that, we can look forward to the day when there will be intelligent beings on Mars. Not little green men or bug-eyed monsters, but settlers from planet Earth.
And most encouraging of all, our future exploration of Mars is now becoming more international and more collaborative. The Russians and the Americans are openly speaking to each other about their plans, and already they're keen to collaborate over certain details. Mars may well be the red planet, but let's hope it's not just a Russian cosmonaut, but an international team who become the first Martians of the future. It would certainly make Percival Lowell a very happy man.
Dan nu in woord en beeld radiopresentator Jan Kooijman.
In radioprogramma 4 gaan wij praten over gruis in het zonnestelsel. Onze gast in die uitzending is Ben Apeldoorn. En Ben Apeldoorn is waarnemingsleider van de werkgroep Meteoren in Leiden. Ben, wat moet ik mij voorstellen bij gruis in het zonnestelsel?
Gruis in het zonnestelsel is hoofdzakelijk afkomstig van kometen, de vuile ijsbergen van het zonnestelsel, en de ringen van planeten als Saturnus en Uranus bestaan er ook uit.
Merken wij op aarde iets van dat gruis?
Ja, het wordt regelmatig door de aarde in haar jaarlijkse baan om de zon opgeveegd. En die gruisdeeltjes komen dan met grote snelheden, tientallen kilometers per seconde, in de dampkring terecht. En dan zien we een zogenaamde vallende ster. En in Nederland gebeurt daar veel onderzoek aan. En dat wordt hoofdzakelijk door amateursterrenkundigen gedaan.
Oh ja? En waarom doen professionals dat niet?
Enerzijds omdat ze er geen tijd voor hebben. Het is erg tijdrovend werk. En anderzijds omdat er gewoon geen geld voor is. En buiten dat is het voor een amateursterrenkundige ook heel boeiend werk. Het is bijna spannend te noemen.
Ja. Vallen er nou ook wel eens hele grote brokken naar beneden?
Dat gebeurt wel eens, zij het vrij zeldzaam. De laatste keer dat dat in deze eeuw gebeurd is en dat het echt een groot brok betrof, was op 30 juni 1908 boven Midden-Siberië. Toen hadden we waarschijnlijk een ontmoeting met een stuk van een komeet.
Ja. Jij doet dat onderzoek al jaren, hè, kun je zeggen. Heb jij nou daar iets bijzonders van geleerd?
Nou, het enige wat we er eigenlijk van geleerd hebben, onder andere, is dat die deeltjes afkomstig moeten zijn van kometen. Dus als het ware, het zijn afvalproducten van kometen. En het is verder zo dat de aarde in haar jaarlijkse baan rond de zon vele zwermen tegenkomt. En dan zien we in die betreffende periode in zo'n jaar ook soms wel eens een regenvallende sterren.
Ja. Heb je ook wel eens iets gevonden?
Ik heb zelf nog nooit iets gevonden. We zijn er in Nederland wel heel dichtbij geweest in april 1972. Toen moet daar ergens in Zuid-Friesland een meteoriet zijn gedropt na een heel heldere vuurbolverschijning.
Ja. Is dat teleurstellend dat je nooit wat vindt?
Dat is wel teleurstellend, maar het is wel te verwachten.
Ja. Goed, Ben, bedankt. Over gruis in het zonnestelsel praten we dus verder in het radioprogramma nummer 4 van deze serie. En dan laten wij ook horen hoe dat waarnemen van die meteoren in zijn werk gaat. Teleac, Radio 5 over